Introduction to functional programming in Python. So, what is functional programming? Functional programming, the emphasis is to use pure functions to transform data. It means the data determines the output, nothing else. There's no state in pure functions. For example, pure function does not modify anything outside the function. For example, the global variables. So the pure functions can be tested independently and will produce the same output for the same input all the time, anytime it is run. Another thing about functional programming is that it focuses on immutable data and avoids side effects, making code more predictable and easier to reason about. Immutable data means the data structure are never modified. They're copied. There obviously is a runtime cost for it, but that is to be borne because the advantages we are getting from having such uh, immutable data structures. Why use functional programming in Python? Python supports functional programming concept and provides several built-in functions and modules for functional programming. The language structure of the function itself make implement the functional programming features in Python pretty straightforward. The code in functional programming is more readable, can be more concise, and is more maintainable because it is self-contained units rather than depending on other parts of the code in a non-traceable way. The advantage of testing and debugging when the code is written as functional units is tremendous, particularly in a large code base. So, key concepts in functional programming, as we have covered in the first slide, pure functions, immutable data, and what we did not cover is higher order functions. Let's go through each and every topic in detail. Pure functions are functions that are always return the same output for a given input and have no side effects. So it produces the same output for the same input at whatever time it runs. It does not depend on anything else. This is particularly valid for multi-threaded and asynchronous programming, where concurrent programming, where it's important that output is predictable irrespective of the when the functions is run. And when it doesn't change anything outside the function, they are very easy to reason about and test. And this is particularly valid for debugging issues. Next, we'll come to immutable data. Immutable data is that cannot be changed once it's created. We do not modify the data structure. Assignment statements. We create new data structure with a copy of the old one. In this way, a lot of issues when it comes to modifying data, particularly in a multi-threaded and asynchronous programming environment, can be eliminated. So it helps avoiding unintended side effects in multi-threaded and asynchronous programming scenarios. And it's much easier to debug such systems when the systems grows large and very randomly occurring issues are reported. Now we go to higher order functions. The higher order functions are functions that can take other functions or arguments and return functions. So they are used to create more abstractions. And Code reuse also is one important thing that be facilitated by higher order function. We will see examples in next slides. Now we go to some particular aspects of functional programming in Python, namely lambda functions, map, filter and reduce, and list comprehensions and generation expressions. Now we go to lambda functions. Lambda functions are anonymous functions that can be defined inline. These are short functions but very useful in many scenarios. And these are particularly useful in case of higher order functions which actually take another function as input. Now we visit map, filter and reduce features. The map is a higher order function that applies the function as first parameter to each element of an iterable, for example a list, and returns a new iterable after applying that function for each element. In case of filter, it returns the another iterable, but it will not contain the elements that does not match the filter function. This also is a higher order function. Now we come to reduce. This actually is facilitates reducing the iterable to a single value by applying a function. For example, addition, sum of the elements of a list. We apply addition function to the list so that the sum of the list can be produced. Examples of map, filter and reduce are produced here. As you can see, the first one is lambda. It's a function that actually squares the input number argument. So what it does is squares each element of the list and return the squared list. In case of map, what it does, it only returns elements which are even, because we are our lambda is here, the filter function here actually checks whether the element is even. Then we come to reduce, where we return the sum of the elements in the list. As you can see, the addition function is being applied here. Now we go to list comprehensions and generator for expressions in Python. List comprehensions provide a concise way to create lists by transforming and filtering authorized tuples. Generator expressions are similar to the list comprehension but generate values on the fly, making them memory efficient for large data sets. Recursion is another important feature of functional programming, where a function calls itself. This can be used to solve many problems that have a recursive structure. That means it's progressively reduced to the same problem until the end, where there's a end case. For example, a factorial function. Here we can see where we use a recursion, because in the definition of factorial we are calling factorial again. Now look at higher order functions in details. These functions take other functions as arguments or return functions and output. It can be used to solve problems under recursive structure. Now look at an example. Here two functions are defined. One is double and then triple. Now we define two higher order function. One is twice, another the compose. The twice, what it does is it takes a function as a parameter and returns a function that applies a function twice. As you can see in f of x. In case of compose, it takes two functions and returns a function which apply the two functions in composition in a sequential manner. Now the example is shown here. First we use the double function. We pass the double function twice, and the return function we pass 10. So double twice, that means the double is applied 4 times here. So when we pass the 10 as a parameter to the higher order function, we get 40. In the second case, where the composition, where treble and triple are applied in sequence, we know that the parameters pass 10. So double and triple. First 10 is doubled and the result is tripled. That's 20 is tripled, so output is 60. Now we look at certain libraries provided as part of the Python standard installations, namely itertools and functools. So itertools provides a set of functions for efficient looping. It includes functions like chain, group by, and product that are useful for functional programming. These are all functional programming patterns that's commonly seen in when we try to structure the code in a functional way. Next, we look at functools. Functools is a module that provides higher order functions or operations for working with callables. So it includes functions like partial, reduce, and LRU cache. And this greatly enhances the capability of structuring the programming workflow in a functional way. Now we look at the best practices and considerations on functional programming. The first obviously is to avoid side effects. This is the very basic of the functional programming. Don't have any side effects, in the sense that anything outside of the scope of the current function is not modified. Next one is keep functions simple, in the sense that to only do one thing and one thing at a time. So functional programming encourages having functions small and simple. Now we look at how to use functional programming judiciously. So avoid side effects, avoid modifying global variables or external state within functions. Use immutable data structures to avoid unintended side effects. Keep functions simple, keep functions small and focused on a single task. Use descriptive names for functions to make codes more readable. Functional programming is not always the best choice for every problem. Use it when makes code more readable, maintainable, and efficient. In conclusion, functional programming in Python provides a powerful way to write concise, readable, maintainable code. By understanding key concepts like pure functions, immutable data, and higher order functions, you can leverage the power of functional programming in your Python projects. Remember to use functional programming judiciously and follow the best practices to ensure your code is efficient and easy to reason about. Thank you for listening.